Welcome back. We are on lesson 27 today, and we're going to talk more about the distributive property and simplifying decimal equations. I think in the last lesson I gave you a glimpse ahead of simplifying decimals. That's okay. We can, get it as we get it. So anyway, example 27.1. We've already been over the distributive property with smaller and simpler terms. Now we're going to move on to something more complicated. We're going to use more variables and multiple variables. So let's start with 27.1. All right, when we use the distributive property with variables, we understand that variables are unknown factors. We don't know what those values are. All we know that is we want to multiply them one against the other. So the thing to do is to apply the distributive rainbow and then squish them together by adding your exponents. So let's begin with xy times y squared. All we have to do is write them together. Here's xy, here's what we are multiplying or distributing, and here's the first term, y squared. We bring down the operation, and then we do the same thing. We write xy, and then we write the second term. All right, now that we have everything distributed, now we can do what I call the squish. And that's where we put all of our like variables together. We put the exponents together. And the way we do that is by putting a little 1 over the top of all of the variables that don't have an exponent, okay? Now we can add the ones that are alike together. This x in this term, there's only one x, so he just comes down here by himself. This y, we have a y1 and a y2. They're both positive. So 1 plus 2 is y3. Okay, y to the third. Because we're multiplying it once and then twice. So 1, 2, 3. 3. All right, now let's do this term. We have an x1 and an x2. 1 plus 2 is 3. So x to the third. We have a y to the 1, and that's the only y on this side. And we have a z to the 1, and that's the only z on this side. This is our answer. See how easy that was? We just write them all down and then add the exponents together. That's all we have to do. Okay, so let's do another one. Let's do 27.2. All right, this one is a little bit more difficult because it has a constant with the variables, and there's a constant with the second term. So that means we can do some actual multiplication. But first, let's do the first term. So just write down 4xy cubed, and then write down the first term next to it, x to the fourth and y. Bring down our operation and write the first part, 4x y to the third, and then write our second term. Now we're going to do the squish, okay? And the squish is where we put it all together. So we have x to the 1, y to the 1, x to the 1, x to the 1, okay? So now we bring down our constant first. We have a 4. There's no other constants to multiply, so it's just a 4. Now let's look at our next variable, and that's an x to the 1. We have an x to the 4. Sometimes it helps if you cross them out as you do them. So we've already done the 4. We have x to the 1 plus x to the 4. 1 and 4 is 5. So that's x to the 5. Okay? Now we're going to do y. We have y to the 3 and y to the 1. 3 plus 1 is 4. So it's y to the 4. Now we bring down our operation again. And now we're going to look for our constants. We know we have two constants over here. So we're going to multiply them together. 4 times 5 is 20. So we can cross those out. We've done those. right? Let's do our x. We have an x to the 1 and an x to the 1. 1 plus 1 is 2. So we've done those. Cross them out. And what do we have left? We have y to the 3 left. We don't have anything to add it to. It's all by itself. This is our answer. This is as far as we can go. All right? It's not super difficult. It just requires a few more steps and a little bit more organization, a little bit more thought. And, crossing them out as you go will help you keep it straight. It'll keep you from missing variables, and it will keep you from adding variables twice. So if you need to use that method, use that method. It's whatever works for you. All right, let's look at 27.3. All right, this one looks a little different, but it's the same thing. It's just that your term that you're distributing was written on the other side. It is the same thing. And if it makes you feel better and makes you see the problem better, just rewrite it. That's all you have to do. Just rewrite it in the way that you're used to seeing it, if that is what helps you to get the right answer. Okay? This is the same as this. We just wrote it differently. So I'm going to cross this out so it doesn't confuse us. All right? Or we're going to use this one. All right? Same thing. We'll do the same steps. So 2x, 2y, and then we have an ay. We bring down our operation, which is a negative or a subtraction, and then we write the first part again, 2x, 2y, and then we write the last part, 4y to the 5th. Now we squish. We have a 2. Let's see, we only have one x, and it's x squared. We have a y. We have it once, twice, so that's 2. And we have an a all by itself, okay? So we did all of these. All right, we're going to bring down our operation one more time. We have two constants here. Let's multiply them. 2 times 4 is 8. Okay. So we did that and that. Now let's see, we have an x squared. The only x we have. And then we have a y once, and then 5. 1 and 5 is 6. So we've done all of those parts. And this is our answer right here. Okay? Awesome. All right, we're going to do one last one, and then we'll move on. 27.4. All right, in this problem, 27.4, I want you to write down the problem and then pause the video, or go ahead and pause the video and write down the problem, solve it, and then press play, and we will walk through it together to make sure that you got all your steps, okay? Then we'll move on to the next part of lesson 27. So go ahead and pause the video. All right, I'm going to assume that you paused and worked it out, so let's move on. We're going to do this the same way. I know it's 3 terms, but you just do each individual term. You just take your time. I'm going to move over here a little bit so we have more room. So I write my original term, and then I write the term that we are multiplying it against. So that'll be the first term right here. All right, I bring down my operation. I rewrite the first factoring term, and now I go to the middle term. 3x5. Bring down my operation, right? Just like I did over here. And then I write the first bit again, 8m squared x, and then I go to the third term, which is 2x. Alright, so now all I have to do is squish everything together and do any multiplication of constants. So let's start at the beginning. 8 times 5 is 40. It's my 8 and my 5 gone. I have an M2 and an M3, so that's M5. I have an X and an X. Those are both to the 1. There's 2 of them, so it's X squared. Bring down my operation. All right, I have 8 and I have a 3. That's 24. 8 times 3 is 24. Let me cross out all the ones that I did over here so I can make sure. So 8 times 3 is 24. I have an M squared. It's the only one I have. So if I have an X to the 1 and an X5, that's X to the 6. Bring down my operation. I have 8 and a 2 as constants. That's 16. Cross those out. And I have M squared. And I have X to the 1 and X to the 1. That's going to be X squared. And I'm done. That's as far as you can go. All right, you guys see how easy that is? Take your time, write down the first term, and then the first term in the parentheses. Then bring down the operation, write the first part down again, and then the next term. Okay, you're just repeating those steps. Then you write down, if you have another term, you bring that operation down, you write this again, and then you write the last term. Then you combine all your like terms, what I call the squish, and there you go. That's your answer. Just keep bringing down your operation each time you do it. All right, if you need to take notes, do so now. I'm going to pause, or you can pause. I'm going to clear the page and move on to the second part of lesson 27. All right, we are in simplifying decimal equations. And I kind of alluded to that in a previous, I think it was lesson 25, where we had a decimal problem. All you're doing is you're going to use multiplication to eliminate a decimal system within your equation. So for instance, here we have 27.5. We're going to, let me write that down for you. It's 0.4 plus 0.02 m equals 4.6. So the way that you eliminate all these decimals is you want to look for the most decimal places, the term with the most decimal places, okay? In that case, it's this term here, 0.02. And this is an m, this is a variable. So you count the number of decimal places, and that's how many zeros you're going to multiply by, okay, behind the 1. So in this case, we have 2 decimal places, so 2 zeros behind the 1 is 100. So we'll multiply each term in this problem by 100, and then we can solve it a little bit easier. It just simplifies the problem for us. So when we multiply 0.4 times 100, that's 2 decimal places, so that ends up being 40. We bring down our operation, multiply this by 2 decimal places, that becomes 2m, okay? Now we bring down our equal sign, and then we multiply this by 2 decimal places. That's what 100 is 2 decimal places, and that becomes 460. Now this is a problem that we can solve more readily. All we have to do now is isolate our variable by subtracting our constant from this side and moving it over to this side, subtracting it from both sides. This cancels. So this becomes 2m equals 460 minus 40 is 420. And then we divide, so we are unfactoring. Divide both sides by 2. This cancels. So this leaves us with m equals 210. All right, you see how easy that was. If we had done this as decimals, we'd get the same answer. It just might be a little bit harder to get there because we have to deal with decimals, and decimals will make your brain hurt if you try to do that in your head. You'd have to have your calculator. But if you multiply everything and just move the decimal point back, then it is so much easier to do this math in your head, or at least on paper. So that's the whole point of doing it like this, all right? So let's do another one. Let me clear the page. Take notes, pause and take notes as often as you need to. So let's do 27.6. All right, so what I'd like for you to do is pause the video and work this problem, and then press play, and let's see if you got the same answer. We'll walk through it together. All right, I'm going to assume that you have pressed pause, and now you're pressing play, or you just pressed play, and we are going to walk through this problem. So the first thing that we need to do is look at the number of decimal places that we have, the biggest number of decimal places that we have. We have 1, 2, 3. So we're going to multiply each one of these by 1,000, because 1,000 will move this decimal back 3 spaces behind the 2. And if it helps you to visualize, just put parenthesis around the whole thing and then count. 1, 2, 3. Okay, that's the biggest number of decimal spaces. So 1, 2, 3, and then put a 1 in front. And that's what you're multiplying. And you don't have to actually whip out your calculator and multiply. All you're doing is moving it back 3 spaces. And this right here just reminds you how many spaces you're moving it back. Okay, so you can keep it straight for each term. That's all I use it for. I don't actually multiply. I just look at my zeros, and my zeros remind me of how many spaces to move that decimal. So 3 zeros, 1, 2, 3. That'd be 2K. All right, I bring down my operation. 3 zeros, 1, 2, 3. So that'd be a 20. Bring down my equal sign. 3 zeros, 3 spaces, 1, 2, 3. So that'd be 4,020. Okay? Now we can solve the problem pretty readily. We're just going to subtract this constant from both sides. That's going to give us 2K here and 4,000 here. Now we're going to divide both sides by 2. K is equal to 2,000. Pretty straightforward, pretty easy. So if you got 2,000 for K, then you solved the problem correctly. And that's all we have for lesson 27. So I will see you in lesson 28.